Assalamu alaikum warahmatullah. As you know, in the yesterday's lecture, we made a discussion on Young's double slit experiment. Okay, Young's double slit experiment. We have the kind of evidence how we can perform this experiment and what exactly the experimental setup of this essential experiment is all about. This is something that we discussed in the last lecture. Okay, so here we will try to visualize some problems which are based on the same experiment here. The problem number first I will just discuss here. Okay, the content of the problem involves, suppose in a Young's double slit experiment. In a Young's double slit experiment means that I need to use here the two slits. Suppose this is a slit first, this is a slit second. Okay, from the planes of the two slits, the screen is at a distance capital D units from the planes of the two slits. Okay, and distance between the two slits is D. Okay. Now, in addition, if there is a source slit in a problem, okay, a source slit here S, means if the slit is ideal here, the light rays come from it. Okay, it will act as an ideal source here. Okay, but as if it's given in a question, like the slit second, it just lies along the line of source slit S. Okay, here we have the source slit and the slit second, it lies along the line of the source slit S, and the source slit, it is also at a distance of same capital D units from the planes of the two slits and all that. Okay, so question basically asks me to calculate for what minimum value of this small d, or what minimum value of this d, so that fringe that appears at the point O on a screen is supposed to be dark. Okay, if the dark fringe that appears at point O on the screen, for what value of d such that such a dark fringe appears at the point O, okay, on the screen. So how we can just calculate this thing here? For that the question gives me a kind of internal hit in a way, like when the dark fringe that is supposed to be appear at the point O on a screen, for that I will just use the condition of district interference, because dark fringe result as a consequence of the district interference. Okay. So for that what I will do, I will just first of all calculate here the power difference, and that power difference I will just equate it the condition for the destructive interference, that is something known for me. Okay, so how I will just calculate here the power difference. Let us assume that the light rays come from the source slit, it just hits the edge of the slit first, and then after it goes this way. Okay, as a consequence of the interference effect, there is an appearance of the dark fringe at point O on the screen. Okay, if this power difference will be known to me, I will just look for this power difference. Okay, first of all, how much it will be? Yes, look, this distance is given from here to there, and the vertical distance d from point S2 to S1 is also given as a d units. So I can just easily calculate this distance. It will be, yes, under root of d square plus d square. Okay, and by symmetry this distance will be also, means S1O, it will be also given as d square plus d square. Okay, so this total distance from S along S1 and from S1 to O, how much it will be? Yes, so my power difference will be here S1O minus, yes, S2O. Okay, S1O from here to there, it is, yes, under root of this much, and from here to there it's of the same, okay, amount. So I can write my SS1O, it will be 2 times SS1, okay, minus SS2O, it will be 2 times SS2. Okay, and this is some kind of symmetry in the problem, and symmetry permits me to do this thing. Okay, no issues there are. So if I will just proceed here, so my 2, it will be, yes, SS1 will be here, correct as SS1 minus SS2, okay? So it will be here 2SS1, that's under root of d square plus d square minus, it will be here d, okay? So this will be my del here, means the power difference I got here, and I will simply equate it, the condition for the jet interference for any order, or the fringe, or the Doric fringe of any order. So it will be as Cn plus 1 or lambda upon 2, okay? This is something that this condition allows me a question to use it, because it's a Doric fringe that appears at the center, okay? The Doric fringe that appears at the center for that question again permits me to put the value of n as 0. No issues there are, okay? So I can look for this power difference here right now. It will be 2 times this. It will be d square plus d square over this power 1 by 2 minus t. It will be simply lambda upon 2, okay? Yes. So how I can just proceed here further. Look, it will be here d. Yes, if I will just use here the binomial expansion, because after using the binomial expansion I will get something very special. How, let me see. So first of all I will just do here one thing. I will just put this capital D common here. What I will get here is, if I will just make the capital D common here, I will get here 1 plus d by d whole square over raised to power 1 over 2, okay? Yes, minus d, it will be as, it will be here lambda upon 2, okay? Now it's a moment to make the use of binomial expansion here. So what I will get here, it will be 2 times, yes, it will be d, it will be 1 plus, yes, I can write here 1 by 2 d square by d t. But I will use here, I will omit here the higher order terms involved in this ratio. It's because the question asks me to look for the minimum value of d, okay? When d will be going to minimum, means that numerator is lesser than the denominator anyway, okay? And its square will be more less. So as a result I am able to omit such a terms here, okay? This is something that the binomial theorem permits me to do, okay? So that's why I just omit here some higher order terms here, okay? So for that, look how, what I will do here further. If d is here, I can just do here one thing. I will just make it common. So I will get here 2d 1 plus 1 half of this d square by d square minus 1, okay? So it will be lambda upon 2, okay? It will be lambda upon 2. So this one will go with this. What I will get here is, so it will be here 2 that will cancel, 1 d will cancel here. Simply I will get here d square upon d, it will be lambda over 2, which implies my d will be simply lambda d by 2, yes, under root, okay? This is indeed the minimum value of d for which the Doric fringe that appears at the point O on the screen, okay? So this is something, the demand I got here. This was the demand from the question indeed. So this minimum value of d will be lambda d upon 2, okay? So my problem ends here. This was something the very important issue from the problem, and we got this condition right now, okay? So let me just look for one more problem regarding the same experiment. If it is given in a question in a Young's, if we just perform the Young's double slit experiment, but we just make the use of two light sources, okay? But the two light sources we are talking about here, they emit the radiations of, they emit the light rays of different wavelengths, okay? The source number 1, just we are talking about whose wavelength, whose light rays are of the wavelength of 480 nanometers, okay? And the source second that's using for to perform the same experiment here possess the wavelength of, okay, the light rays emitted from the source second have the wavelength of this much, okay? If it is given in a question, in the Young's double slit experiment, the distance between the two slits, as if it's given like it is 5 millimeter, okay? And the distance of the screen from the slits, it's given as 1 meter, okay? Yes. So I need to look for what's the separation of the screen of, if the third, when we talk about the third order bright fringe, due to the interference pattern of the two light sources, in order to perform the Young's double slit experiment for the third order bright fringe, because when we use this light source we have the third order bright fringe, and when we use this light source we have the third order bright fringe. But what's the distance between these third order bright fringes? They just appear on the screen in the Young's double slit experiment. This is something that I need to calculate, okay? I need to calculate basically here what the distance between the third order bright fringes here. How distant the third order bright fringes will be when we perform the Young's double slit experiment by using the two light sources whose wavelengths are given, and the distance between the two slits and how apart the screen is from the plane of the slits is also given, okay? How I can just look for this kind of problem, okay? So for that I will just use the very basic condition that we got regarding the path difference in the Young's double slit experiment. What is that basically? When we talk about the path difference, it is just like d sine of theta, but the question asks me about the bright fringe, means that I need to use here the condition for the constructive interference, okay? But we just use here in double slit experiment we are going to use what I can say the small angle approximation, because fringes are not relatively very large distances from one another, so it's better to use the small angle approximation, which implies my d sine of, yes, if my angle is here small, okay, so if my angle is here small, so I can use small angle approximation. Under the small angle approximation, my sine of angle is simply angle, so it will be as n lambda, okay? So it means del theta, it will be simply n lambda over d, okay? But here when we use the third order bright fringe, we'll have here lambda 2 minus lambda 1, okay? Okay, I hope that you got it, because the change in the angular fringe width, it will be equal to the n by d, because n is same for and d is not, we are changing the distance between the slits, but the wavelengths we use from the different sources are the different, okay? So here we got this condition here, okay? So it's not enough to do here everything on the basis of this, but I will use it in a way like I will just use it, okay? How? So when we talk about the appearance of fringe, position of the fringe with respect, really to the centermost point on the screen, how we can just look for that kind of calculation. So for that I will use here my yn, it will be simply as, that will be perpendicular over base, that's d tan of del theta, okay? This is something that we got here, okay? So I got here my del theta is something n and lambda by d, n by d lambda 2 minus lambda 1, okay? I don't need to care about here the lambda 2 lambda 1, it's given, and is also given distance between the slits is also given. So here I should just go correctly with how I can just look for how the same order fringes are going to be distant by using the different light source to show the interference pattern, okay? For that, what I will do here, I can use yn will be equal to yes, it will be here d, and the small angle approximation, tangent of theta is also theta. Okay, so I can put the value here. It will be n d lambda 2 minus lambda 1. Okay, if I will just switch the value of the set parameters here, what I will get? Yes, so I got here dn by d lambda 2 minus lambda 1. This is something, it is means every parameter has its value that's given from the problem, so I don't need to vary here. So how the screen is distant from the slits, that's 1 meter. Okay, question asks about the third order bright fringe. So here d is here, yes, it's 5 millimeter, means 5 to the power 10. It is lambda 2 is 600, lambda 1 is 480, 1 nanometer is, as you know, it's 10 to the power minus 9. Okay, yes, so here it will be, yes, it will be 3 by 5. Yes, it will be 120 into 10 to the power, this will go with this, it will be simply 10 to the power minus 6. Okay, so it will be 5 2s, 5 4s. Okay, so here it will be 12, it will be 72 into 10 to the power minus 6 meter. Okay, that I can write is 7.2 into 10 to the power minus, okay, 5 meter. Okay, this is how the slits will be apart from one another. Third order bright fringes will be, apart from one another if we will just use the different light source in order to perform our Young's double slit experiment. Okay, this is something that we got here. Okay, so this problem also ends here. This problem was based on the same experiment. Okay, this was a good problem indeed. Okay, because we are going to make the two sources here to get the, what exactly question was asked us to calculate. So this discussion ends here. Thank you.